if we put a point here, is it inside the closed curve L or outside? It doesn't have a meaning, okay? It's not like we can't cross to here, because we can go around and get to, you see what I mean? It's not inside and it's not outside. This closed curve it's like if we had this, it's not a torus, but if my fingers were this L are my fingers, like it's going around the toilet paper through the hole, okay? So, and if we have a point on the toilet paper, like let's say I'm painting where my fingers went. So we have this, you can see the purple, okay, and we go like that, and also inside I can't paint, but you understand it's also going inside, so it's like this. This curve, this closed curve is called L. In our example, it's like if we call it Joseph or something, it's like it's his name, this one in particular. And now we make a dot, like this dot. So for example, if we have this and we put a dot here, okay? Okay, here. So is it inside the curve or outside the curve? It has no meaning, because this whole thing is you can walk, the little bug can walk here and can walk here, and there isn't inside and outside. It's not like before when we had Australia and we had things really inside and outside. This point is inside, this point is outside. This is a closed curve and there isn't inside and outside, because this surface has a hole and this curve is going inside the hole. And another possibility that there wouldn't be an inside and outside is if, one second, is if we make another closed curve, like this one, going around the hole, okay, like this, and we call it P, okay. This is another one, like if that one was Joseph, this is, I don't know, Jacob or something. This is P, another closed curve, and it's going around the hole. The other one went through the hole, okay, like through the toilet paper. Now we are talking about if we have, one second, Okay, forget L. Now we have P, another closed curve, but still on a not a simply connected shape, a shape with a hole, a torus or a donut. If we make a line like this, okay, round and round the hole, okay, this is going around, sorry, this is going around the hole, this is, forget L from before, this is the hole, and it encircles, it goes around the hole. So if we put again a point somewhere, like here or here, it doesn't matter. There isn't an inside and outside, like inside Australia or outside Australia. Okay, because if the little bug wants to walk to the other side, so-called, it goes like around here, through the hole, and comes to here. Okay, so this is all connected. No, connected is not a good word, it will confuse you. Forget connected. There isn't an inside and outside. No inside and outside. It's like if we put here a point, okay? We could go through the hole, come from here, and be in so-called the other side. There aren't inside and outside. Okay. Oh, and another thing, if we had both L and P, one more thing, if we had both these two closed curves, L that we talked about before, okay, that went like this around through the hole, and P, this is A, and P that went around, they on not on a simply connected shape, but on a shape with one hole, they do have a situation of one meeting point, one cutting. Okay? They cut each other here in one point. Before we said that one point is not possible, because if we do cut, if we go inside, we have to go outside. Okay, so this was not an option, because we didn't call it cutting at all if they just touch. But if they cut, this is not cutting. But if they cut inside, they have to cut outside. This is on a simply connected shape. But, okay, so this doesn't exist. On a simply connected shape, we had either zero cutting or two cutting. Now we have a possibility of two closed curves that touch each other in one point. It's possible. One is going like this, another one is going like this. It's possible to have one cutting point, because this is a different kind of shape. It's not simply connected, it's not like a sphere, it's like a torus. It has one hole. Okay. Okay, we'll erase it. And this is invariant to all shapes that has what we talked about is not special to torus. It has not special to donuts. It has this is true in every shape that has one hole. Okay.